Thank you, Teddy and Edgar, and welcome.
Thank you, Paul, for the introduction, and thank you to everyone for giving us the forum to share what we've been working on. I know I was telling Paul earlier that we're excited to share what we've been working on, but I'm also excited to learn about what you guys think and get any feedback about what you guys have on what we're building. So yeah, without further ado, I'll do a short introduction of myself, and then Eddie, maybe you can introduce yourself, and we can move on. But yeah, my name's Teddy. I am a software engineer at Kurtosis. I've been working here for about a year and a half, and yeah, I'm excited to share about what we've been building the past few months. Edgy, I'll kick it off, and then I'll take it from there.
Cool. Well, my name is Edgar. I'm engineer as well at Kurtosis. I joined a little bit later than Ted, about a year now. Before that, I was working in Palantir for 7 years. Before that, I was doing PhD in material science and movement maker here, so like a lot of movement, but like really happy to be at Kurtosis.
Yeah. Cool. Before I joined, I was finishing my degree. So I'm excited that Kurtosis is my first work opportunity. It's been a great journey so far. But yeah, to get into it, let's start. I think I'll start off by talking about something that we're all very familiar with and that we all interface with on a day-to-day basis. But just for the sake of establishing some foundation, I'll review some common ground on what it looks like to develop on Kubernetes clusters today. So from right to left, I've got generally a very high-level overview of the software development lifecycle. On the left, we start all the way in development locally. We've got our developers that are working on their various microservices, be it features, bug fixes, etc. They'll make these changes locally. And then usually they'll have some sort of development environment or where they'll do some testing. They'll run unit tests and they'll run integration tests locally. And then once they've got some local confidence, they'll push that up into GitHub, where usually some CI/CD release process occurs and allows these developers to get some development versions of the services that they're testing into some pre-production Kubernetes clusters. And depending on the team and depending on the scale of the application, depending on the number of microservices that are in that Kubernetes cluster, there could be a variety of different pre-production clusters, but some sort of pre-production clusters that mirror the production environment. And then once some testing has gone on and once we've gained confidence that these features are ready to go, we'll push that to production. Now, two things that I want to highlight in this progress of the software development lifecycle. At some point, there is this kind of transition between a developer's world into the Kubernetes platform DevOps team world, where there's kind of a handoff where the developer is saying, hey, here are my development version of my services. Can you, the Kubernetes engineer, DevOps platform team, offer me some sort of platform where I can get this version tested in a production-like environment? And so there's that handoff where we're kind of offering this platform for developers. And then the second thing that I wanted to highlight is that within this process, the faster, usually we put time into getting into these pre-production clusters as fast as possible. We put time into making sure that the process to getting into those pre-production clusters is as fast as possible. And why do we do that? Well, we know that there is a whole host of issues that we can only kind of realize by getting these services into a production-like environment, right? There's always it works on my local machine. These unit tests are running, these integration tests are running, but there is something about the production environment that is always different and usually causes a whole class of bugs. And so the faster that we can get our dev versions into that pre-production or production-like environment, hopefully the faster this entire process can take. And so what's a common general approach that kind of teams can take to getting these services tested into production-like environments? Well, a very common thing that teams will do is they will create multiple pre-production clusters, a dev cluster, a staging cluster, a QA cluster, and it depends on the requirements and the scale of your team, but these could be persistent environments, so persistent dev and staging environments that teams have access to. They could be shared across many teams, or they could be more ephemeral. So maybe these are provisioned on a pull request or maybe we've offered some platform for teams to have their own environments, but generally there are just multiple production clusters that we can use to test out changes. And so this is great. We have the ability to test our changes with safety before they go into production in a production-like environment, which is what we want. But let's get deeper into some of the pros and cons of this approach. So on the pro side, great. We've already talked about that. We've got this speed to production-like environment, which is very important. And then also by having everything in different clusters and kind of having this copy paste of the production-like environment in multiple environments, we get the maximal isolation and safety of the environments that we want. Well, again, it kind of depends on if you have a shared environments, but generally by separating it out into different clusters, you can get a very isolated environment to test your changes. But what are some cons of this approach? Well, first, and again, it depends on the amount of pre-production clusters you have. I know Edgy, we've seen teams be using 3 to almost 9, depending on their setup from just different product and research interviews that we've talked with. But that's a large maintenance surface areas for teams to be working with. And really the burden falls on the DevOps and the platform engineers to be servicing that platform and maintaining those when it comes to upgrades and it comes to configurations and such. And then with those pre-production environments, you've got a lot of resource usage. And with that resource usage and that duplication, you're going to have increased cloud spending costs or, just costs in general for maintaining those clusters. And then again, I know that we mentioned that we get that speed to production-like environment, but depending on the amount of clusters you have and the transition that you have from actually getting services propagated through the stages, you could actually end up having a slower release process than you might be able to get. And then also, and again, this is dependent on your setup, but it could require coordination amongst teams. If you got a shared environment, for example, and 2 teams are trying to push a feature and one is depending on some state in the database, but then another feature accidentally corrupts that state, you now have this coordination that we need to resolve between teams who are trying to get their dev versions of services tested in a cluster. So is there a way to do better than this? Is there a way that we can address some of those cons while still maintaining the pros of having those pre-production clusters? And an approach that we've seen that some teams are looking into recently and is pretty also common is having some sort of ability to enable namespace-based dev environment deploys. So this is leveraging the nice feature that Kubernetes gives us of namespaces, where namespaces provide us this nice isolation where we can deploy pods and services and deployment specs into, and they have their own DNS and networking, isolation, etc. And so we can use this feature to give us different isolated logical views of a cluster. But what are some pros and cons of this approach? So you've got a lower maintenance service area. Let's assume that we've got our production cluster and you've got your pre-production cluster, which we've now minimized into one, where we're just deploying namespaces into. We still get that ability to get into a production-like environment, and you've got lower resource usage because you're not duplicating the entire cluster. And depending on how you're reusing or maybe sharing resources across namespaces, specifically stateful services, you could be lowering your resource usage, or you actually could be increasing them when you don't need to, which gets us into the cons, which is that to actually configure this or get this working properly, the burden falls onto the Kubernetes and the DevOps management teams to really carefully implement the necessary role-based access control policies, making sure that only the people who need access to a certain namespace get access to that namespace for whatever workflows that they're working on. You need to implement careful management of resource quotas and network routing policies. And then also you have this question of, okay, well, what do we do with stateful services and stateful sets? Do we share them across the namespaces? Usually we end up having to duplicate them across all the namespaces. So there's still some duplication of resources that we could potentially save on. And so this kind of brings us to what we've been thinking about with Kardinal, which is there a way to kind of get all 3? And what do I mean when we say all 3? Kind of what I've been talking about in the past, few minutes are these, I've been alluding to these 3 different axes and trade-offs that we're making with all these approaches, which is we want that speed to production, a production-like environment, but in order to offer that, we're kind of implicitly making some sort of trade-offs between the resource usage and the cost that we're going to be spending, and also the desired levels of isolation that we want depending on the workflows that we have. And so what do I mean by isolation? I mean like stateful isolation, right? Maybe for a workflow, I'm okay with sharing the database in that state to test whatever version that I'm working on. But in another scenario, maybe I'm not. I really need my own database to be doing that testing. And so again, with the namespace-based dev deploys in the production environment, we're kind of making that trade-off. And with Cardinal, we thought, okay, is there a way that we can somehow get all three of these things? Is there a way that we can maintain that similarity to a production-like environment while still really maximizing the resource usage and cost savings, reusing the things that we can reuse for the workflows that allow that, but then also duplicating where needed for the state that we need to duplicate. And by getting that maximum reuse, thus getting some cost savings, and then again, enabling the desired isolation levels, really being able to configure what isolation levels you need for the workflow that you're working on. And so these are that kind of the things that we are trying to answer with the product that we've been working on over the past few months, Cardinal. And so over the next few slides, I'm going to be explaining to you what are some of the primitives that we have created within this product to offer this. And then I'll do a deep dive into the architecture and the actual technical implementation. And I'll end it off by showing a demo of some of these things in action. So the first primitive that we are kind of working with is the idea of, there we go. Cool. So the first primitive that we're kind of working with are flows. So to take this back a little bit and think about it a little bit from a higher level, the way that we can think of a cluster is as a kind of topology of services with some interconnected connections between them. Services that depend on each other where they, depending on whether it's traffic flowing in some direction or a service depending on a database, depending on some database state. And all these services within your cluster create this topology of services and connections between these services. And really, that comprises your base topology. And then a developer will come along and they'll say, okay, well, I want to be testing this development version of a service. It has this feature implemented into it. And actually, in order to test that front-end feature, I'm going to need this back-end API change. And so I've got to test these two different versions of my service. And so what they're really saying is that they actually want a slightly different topology in order to enable their workflow. They want a topology that's actually leveraging the dev versions of the services, but everything else can stay the same. Great. And then we've got this second developer who's trying to enable this other workflow. And this developer says, okay, so I actually want to be changing this backend API, but then in order to do that, they actually need to be duplicating the database because their change depends on some sort of seeded state that they want to be testing against. And so they're saying, okay, I actually want to be working on the base topology, but with a different modified topology with a duplicated stateful service and a dev version of my stateless service. And so what's really happening here is when we're trying to enable these workflows is we're creating these logical different layers or different logical topologies. And what we try and do in Cardinal is merge all of these into one topology that is then implemented in the cluster. This way, we can say, okay, the abstraction that a developer can have in their head is that they're working with their own workflow, or flow as we like to call it, where they can think of their traffic being routed through a certain flow that is going through the topology. But in reality, it's the cluster that's implementing all these different flows that can coexist. And this way, you can implement all of the dev workflows that a developer wants, or that numerous developers are in fact working on at the same time, while maintaining the different isolation guarantees for each of the workflows and traffic flowing the proper way. And then also, most importantly, reusing a lot of the services within that system. So, by concatenating them, if it's possible where two workflows can coexist with each other by using the same stateless service, let's do that and let's reuse that service. And when you end up translating that to a cluster with potentially tens of hundreds of services, you'll end up being able to reuse a lot of services and thus incur a lot of savings on resource usage and costs by concatenating them into the same flow. So there's this idea of flows, and why we like to call them flows is because a developer kind of has this idea that the traffic they're initiating when they are working on their own workflow takes a certain flow within a cluster that goes through the dev versions and that they need to be testing. And this is kind of a diagram of how this ends up looking like to us, right? So we could potentially be simultaneously at one time testing multiple different versions of an analytics service, multiple different versions of an order service, then based on the different requirements of the workflow, either duplicating the stateful services where they need to be duplicated or not. And the idea is that Cardinal will handle making sure that traffic is being routed to the proper versions of each of the services and end up in the proper version of the stateful services, etc. So, okay, but then a huge question comes up, which is, great, this is awesome. I can reuse stateless services that can be reused, and then I'll duplicate the dev versions that can be duplicated for the different dev workflows that I'm on. And then I'll get some traffic routing going so that I'm making sure that traffic is flowing through the right different versions of the dev versions of stateless services. But how is it that we actually handle the really important question of state isolation and stateful services, and also external services, so services that are outside the cluster, like APIs and such? So that is handled by this ecosystem that we have with plugins. So, I think I'm missing a slide here, actually. No, this is a duplicated slide. So we should be able to go to, great. So with this plugin ecosystem, and so what we want to be enabling with plugins is the ability to, depending on your needs as a team, handle those stateful and external services in a way that implements the levels of isolation you need for whatever flow you're working on. So we have this plugin API that consists of two functions called create flow and delete flow. And anytime that Kardinal detects that we're going to need to create a dev version of a stateful or an external service for a flow that you're working on at any time, the create flow will, the create flow function will get called on the plugin that you're indicating we should use to handle that stateful service. And so what gets passed into the create flow function is for a stateful service, the deployment spec of the base deployment, the base stateful service. So let's say that we have a Postgres database that we want to create a dev version of. The base version of that Postgres database will get passed in via the service spec of the Postgres database, and the deployment spec of the Postgres database will get passed into this create flow function. And then the plugin author will define the semantics of what it means to have a dev Postgres version of the database. And the way that they implement those semantics are by making changes to the deployment spec. And so what this could mean is that, okay, we're going to create a new dev database, we're going to seed it with some initial data, and then we're going to return the updated maybe host name and database table and user that we want the new deployment spec to use. And then that gets returned to the Kardinal engine, and the Kardinal engine will create a dev version of that Postgres database using the modified deployment spec. And then the plugin author can also pass in information through this config map, and that information can be used in the delete flow function to determine how we can actually clean up the entities from that stateful service. So then anytime Kardinal goes ahead and you say, I need to delete a flow, Kardinal will say, oh, this flow contains this dev version of the stateful service. I'm going to call the delete flow function on this plugin, where the plugin author has defined the semantics to actually clean up all the resources from that development version of the stateful service that you've indicated. And if needed, they'll use any data from this config map to actually delete the things that they need. And I'll kind of give some examples of that later to make that more concrete. But let's see how we can actually apply that to an example. So for a stateful service, just like I gave the example of Postgres, in this Kubernetes manifest, we've got this stateful service of Postgres defined. We can use Kardinal annotations. These are annotations that we'll just add to the Kubernetes manifest of our application that tells the Kardinal engine, hey, this service is stateful. And whenever we have a flow that relies on this stateful service, let's use this plugin. And so then when the flow is created, we'll call the create flow API, which I just was discussing about, and that will get passed in this seed script that will then seed the database, seed the Postgres database with some information, and then it will return a modified deployment spec that we will then use for that dev version of the database. And then when we want to clean things up, we'll call delete flow, and then that'll just get rid of the database. Cool. And how will this work for an external service? So to give an example of an external service, maybe we are using a database that relies on for example, Neon database. If anyone's not familiar, it's a hosted managed Postgres database that offers some branching features. So let's say our cart service in our application actually relies on this Neon database that's external to the cluster. In this case, we would put the plugin on the dependent service, in this case, the cart service. And so anytime a workflow is created that then relies on this cart service, the Kardinal engine will call create flow on the Neon database plugin. And the plugin author, who has coded some Python over here, I know you probably can't maybe read all of it, but the plugin author, me in this case, has implemented the semantics of what it means to have a dev version of that Neon database that we can use. And with external services, the deployment spec of the dependent service gets passed in. And so the logic for the NeonDB plugin create flow logic will be, hey, let's make some API calls to create a new Neon database branch that is based on the main or base Neon database branch. And then let's return a cart service that is now pointing to the dev Neon database branch instead. And so now we've got a dev version of the cart service that points to a dev version of the Neon database, which I have implemented as the plugin author semantically via this create flow plugin API. And then when we want to delete delete or clean up the resources that have been created by the stateful external service, we will call the delete flow. And that's where we can actually leverage the config map, where we'll pass in some API keys, the product ID and the dev branch ID, to use that information to then clean up that dev branch that I created with Neon. So to kind of summarize, what we can use and leverage these plugins to give this configurability to the user to define how do you actually want to handle the isolation levels for your stateful and external services within your application. Great. So I've kind of done some talking about the Kardinal primitives and some of the primitives that we're working with, namely flows and plugins. And now we'll do a little bit of a deep dive into the architecture just to show you guys how this is working behind the scenes and how we've implemented this behind the scenes. So some four main entities that we're working with. You've got the CLI, that is the thing that the user is interacting with to create these flows, delete these flows, and deploy the application. And then the CLI will deploy the Kubernetes application to the cluster via the Kardinal control plane. The control plane, which we'll get into, is the thing that does the bulk of the computing to make sure that a cluster is in the desired state that it needs to be to implement all the desired flows that developers are working with. The Kardinal front end is the thing that allows us to visualize via graphical user interface all the flows that we're working with. And then this K8s cluster that I've got here is the Kubernetes cluster, where the services are deployed into the namespace of the user. So it says namespace Kardinal here. This is whatever namespace the user is using to deploy their services into. But then we've created this namespace that's deployed some Kardinal specific things, namely the manager, which is a sidecar that's running in this namespace that is constantly polling the control plane for the most updated cluster topology or state of the cluster that the cluster needs to be in. The Kardinal manager then applies that to the cluster to make sure that the cluster stays up to date with the state it needs to be on to implement all the flows. And then we've got this Istio control plane and trace router, which I'll talk about in a second. So first things first, let's talk about how we are actually doing some of this. How are we actually implementing all of those flows using the cluster topology and the control service? So kind of to start at the very beginning, when you deploy an application using when you deploy an application using the Kardinal CLI, you'll pass in a Kubernetes manifest to us. This manifest could have a few Kardinal annotations, or it could have a ton of Kardinal annotations, as I'll show in the demo. And then we will create an internal representation of your Kubernetes cluster via cluster topology. We'll do some resolving and validating of it based on the information that you've given us via the annotations of some of the dependencies that exist within it. What is the ingress or the entry point into the cluster? And then this is where the real magic happens. So for each flow configuration that a user has given us, a flow configuration consisting of, okay, what's the target service of this flow? What development version of a service do we want to be using? What's the image for that development version of the service that we want to be using? What are the stateful kind of modes that we want to be using the service in? So what are the stateful plugins that we want to be using for this flow? For each of these flow configurations, we will resolve that against the base topology and then create an entirely new topology that has that flow implemented into that topology. And then now we've got all these logical isolated layers, which we're representing internally. Those get merged into one workload or into one cluster topology that implements all of these flows, reusing the stateless services that can be reused, while making sure that we've duplicated and created the dev versions of the stateless and the stateful services that we need for all the flows. And then that cluster topology gets translated into cluster resources, which are really the Kubernetes and the Istio primitives that we'll actually be using to implement the different flows in your cluster. So these are the actual services and deployment specs. And then we leverage Istio, which we'll get into on the next slide, under the hood to actually do a lot of the traffic routing that will enable the flow, the traffic flows. So yeah, you can just imagine that based on each flow, we will resolve that against the base topology, create a whole new topology, and then there's this whole merging of these kind of different parallel universes that we want to exist simultaneously within your Kubernetes cluster. Great. And then, cool. And so then let's talk about how traffic is routed within our system. So the big thing that we're kind of, that I was kind of mentioning earlier is like, okay, is there a way where we can reuse the state list services that can be reused, right? So if we've got an order service and this order service can be reused across multiple flows, how can we actually reuse that order service? Or if we've got a stateless service that we are testing 3 different versions against, how do we make sure that traffic is being routed correctly to each of those different versions of the stateless services? And so that's where we use Istio and Envoy filters under the hood. So how do we actually do this? So for each flow, a client client request that is generated that is targeting a certain flow will get passed into our Istio ingress gateway. And the key thing here is we'll use this trace routing service where we'll attach a trace ID for a flow. And so each flow will get a unique trace ID that determines how that request should be routed through the system. And then this trace routing service will tell us, okay, based on this flow and based on the trace ID, what service should we actually route it to? What's the destination for that request? And then we'll use an Istio virtual service, which then determines, okay, based on the destination header, which gets returned to us from after calling our routing service, what version of the stateless service do we actually need to hit to properly implement where that request needs to go, depending on the flow that it's targeting. And then the service will and then we'll use an Envoy filter that will determine the trace ID based on the trace ID. So we process this request. If we should process this request, great, process it. And then one caveat here is that we need to add, for all the services, we have to add logic to the services via tracing system to actually forward all of these trace IDs along with all the HTTP requests. And so each kind of stateless service needs to add logic that forwards this Kardinal trace ID. And on top of that, the second caveat is that these services need to be HTTP services, so we can actually do the manipulations of passing along that header for the Kardinal to determine the proper destination for requests. And I'll get into how some of that works a little bit later. But yep. And then when requests are coming out of a service, we'll once again check what's the destination for that service, route to the new destination, and the whole process will repeat itself. So high level idea is that we need to determine what version of services different initiated client requests need to flow through. And we do that using Istio virtual services and Envoy filters under the hood. Cool. So I think that at this point, maybe it would be a great time to actually do this demo that should make a lot of what I'm saying a lot more concrete. So I'm going to be doing a live demo. I know that these are cursed, but just in case, I've got a backup video in case anything breaks along the flow. So if that sounds good to everybody, I'll switch over from the slides and get started with showing off some of these Kardinal features. How's that sound? Good, Paul?
Yeah.
Let's do it.
Good luck.
Let's see. Great. So can everybody see my screen here?
Yeah, it's small. You need to zoom in.
Sounds good. Let's zoom in on this terminal a little bit. Cool. How's the terminal? Can people see what I'm typing in the terminal?
Oh, it's way small.
Yeah, the upper one is much better than the lower.
Let's see. Ooh, resize. All right, you know what? Why don't we use, how can I increase this size of this thing?
Command plus, maybe it works. I don't know if it is universal.
Command plus is not working on that. Okay, let's try and do this. I'll use this terminal. How's this terminal? Can everyone see this one?
Yep.
Yep.
Great. I'm just gonna set some things up here. Great. Okay, cool. Just checking one more time. You guys can see what I'm typing. Should I increase this a little bit more?
We do one more. Yep. Yeah, that's good. Good. There. That's good.
Great. All right, great. So what I'll be doing is I'll be demoing the Cardinal engine, the front end, the control plane, and the Cardinal manager all running on my local system. And I'll be kind of demoing a few levels of where we can take Cardinal in terms of the workflows that we want to do. So first things first, I'm going to go ahead and I'm going to deploy the Cardinal manager. That's that sidecar that I was talking about earlier. This is the thing that will run inside of a user's Kubernetes cluster and constantly apply the desired cluster resources that implement the desired topology that we want to implement based on our flows. So I'll do that using a Cardinal manager deploy. And because I'm working on a local version of my, I'm working off of a Minikube local cluster, I will tell it to deploy there. And then one other thing that I'm going to have to do is just tell this that I'm in dev mode. Great. And cool. So the first thing that we are going to deploy to our cluster using Cardinal is this Kubernetes application. It has been kind of been the one that I've been referencing throughout the presentation. It is the Kubernetes manifest for a basic online boutique store application. So it's got a front end, it's got a service that manages the cart information, it's got a Postgres database that contains all the information about what's on our cart, and it's got a product catalog service as well that gives us information about what products that are actually in our boutique at any one time. And there's only one non-Kubernetes or one Cardinal specific thing that I'm going to be adding in this first iteration of this, which is this ingress information. So I'm going to add these annotations to say this front end external load balancer is the actual ingress to my application. It's how traffic is going to come into it. I'll indicate that saying that this is the ingress and the host that we'll use is, ooh, can everyone hear me? Great. And then I'm going to indicate this by saying that this is the, this is the URL or the host name that we can access it at. So I'll go ahead and copy the path, and then we'll go ahead and deploy to it. We'll go ahead and deploy this. Oop. Let's see. And here's where live demos are not the best. Let's try this one more time. I'm going to restart my control service. And then I'm going to make sure that this is the correct command. All right, I'm not going to debug where that's coming from right now. I may try one more thing, which is all right. We may be aborting live demo early. I did pull from main very recently, even though I did run a version of this right before the meetup. Let me just check one more thing.
Mary demos are especially dangerous.
All right, we're gonna default to the video that I recorded just before this. Apologies for that, guys. Cool. Can everybody see this? All right. I promise this will be just as exciting, if not more. Only caveat is that I'm going to have to walk you through some of the commands that I'm typing because I didn't properly adjust my terminal for the size differences. But cool. So as I was trying to do, we are going to deploy the base version of this Kubernetes manifest. So and it's got that ingress and it's got that host annotation on it. We're going to deploy it to the Kardinal control plane, and great. Now we've got that product service, and now we've got the application visualized in the control front end. So the control front end is saying, okay, here are all the services that are in your application. We've got your front end, we've got your card service, we've got your Postgres database, and we've got your product catalog service. As you can see, there's no kind of visualization dependencies between these, but that's okay for now. Let's keep rocking with it. What I'm doing now is I'm running Kardinal flow create. And again, apologies that you guys can't see the command. What this command is doing is it's saying, cool, let's create a new flow. And in this flow, I want to change the front end service to be using a dev image of the front end service to reflect the changes that I'm working on. So we're going to create that flow. That will then get passed to the control plane. The control plane will then adjust our topology to implement this flow within our cluster. And we can access that flow via so here's the updated front end. We can see that we've got both versions of the front end running side by side within the cluster while maintaining the original versions of the cart service, Postgres service, and the product catalog service. And let's actually play around with it. It may take some time to, there we go. And so you can see this is a dev version. It's got a change to it. And I can empty the cart. I can add things to it. One thing you'll notice is that there's no state isolation in this flow. So if you, well, I actually just deleted the cart, but if you notice the database was reflecting the same cart for both the development version and the prod version of these services, but we'll address that in a future iteration. Cool. So now I'm going to be deploying a new version of this Kubernetes application. This Kubernetes application has a few more Kardinal annotations on it. Specifically, it's got the dependencies annotations on it. So this is how users can indicate to us what the dependencies within their topology looks like. And with these dependencies, we can do things that are a lot more interesting. So here we're defining this cart service dependency on a Postgres database. We're also telling it what protocol it communicates in. I addressed this earlier about HTTP versus non-HTTP, but this will tell us whether we need to duplicate a service or a stateless service or not, depending on whether we'll be able to route traffic with it properly. And then I'm adding, so you can see the other dependencies here. Great. So now it's deployed. Cool. Here we can see that with this updated Kubernetes manifest, with the annotations of the dependencies, our front end is able to visualize the updated topology with the kind of the representation of the dependencies. So the front end depends on the cart service depends on the Postgres database, and the front end depends on the product catalog service. And with that information, we can use that to help create better flows. So here, what am I going to do? I'm going to create a flow with a front end. And so let's say that it is Black Friday and I'm on the front end team and we want to be testing out a feature where now different products can go on sale. So I want to be testing a dev version of this front end that I've just created. And so I'll create a flow for that. It'll create this new front end flow. This will take a second to render in our topology. I forgot. In order for this front end change to actually work, I need to be using the updated product catalog service API that the backend team has just made me, and I need to be using that dev service image. Luckily, Cardinal can handle multiple services at one time within a flow. So let's demo how we can do that. Great. And so now we can see the updated flow has a dev version of the front end and a dev version of the product catalog service. That now the dev version of the front end, traffic will flow from the dev version of the front end to the dev version of the product catalog service using that tracing system. This might take a second. Great. And so, oh, that's the production version. I missed it there. There we go. And so now we can see that we've got our Black Friday feature in a flow implemented into our cluster. You can see that now all these services have discounts on them. That's great. And this is because we're using that dev version of the product catalog service. But once again, you can see that the carts for both our production flow and our dev flow are the same. And that's because they're using the same database. So how can we get around that? The first thing we're going to do is we're going to delete that flow, and then cool. And then we'll get onto our the kind of the final iteration of what we can do with Cardinal, which is seeing how we can use Cardinal and the plugin system that I mentioned to actually get a state isolation level that we want for a feature that we're testing. So let's say now we are testing this feature, but we want to make sure that the database that I'm using is completely separate from the database that the production flows is using. And so we can do that by doing two things. We'll add two more annotations. So the first thing we'll do is we'll add a plugin annotation, and we'll actually add a plugin annotation for the free currency API. So this is the API that the front end uses to actually get currency information. And we're going to add this to our Kubernetes app just so that we can, the plugin actually won't do anything in this case. It'll use the same API key. It won't use a dev API key, even though we can set it to use a dev API key if we wanted to. But we'll just add this so that this external service actually gets rendered in the application. So there's an example of how we can add an external service, and note how that external service got added onto the dependent service, which was the front end application. But then here's where the really interesting thing comes in, which is we added two annotations, one to the Postgres service, one to indicate, hey, this is actually a stateful service. So we're going to maybe want to duplicate this for some flows that we're creating. And then two, when we actually do have a flow that relies on this Postgres service, let's leverage this plugin. And this plugin will seed this Postgres database with some data to start off with, and then it'll return a modified deployment spec for that database that we should use when actually using that flow. So those are the two things that we've added. And now I'm going to create that same flow from before, but instead I'm going to be using it on this new deployed application with the added plugin annotations for the isolation level that we want. Great. So you can see the only difference in the base topology flow is that now we've got this free currency API rendered as a service within the topology. So this is just a nice way to actually bring in external services to be rendered within the topology. And then the real magic happens when I call a create flow that leverages both the front end and the product catalog service. So cool. Let's dive deep into actually what's going on here. So what happened here was that now that we knew that Postgres was a stateful service, Cardinal detected that this front end at some endpoint in the topology depended on a stateful service. And because the front end depends on the card service and the card service depends on the Postgres. And we saw that that plugin was there. So we're actually gonna have to duplicate this Postgres database, and we're gonna do it using the plugin that we annotated on the Postgres service. And then you'll notice also that the card service is also duplicated. And this goes back to the trace routing. So the trace routing mechanism only works for a communication that is HTTP, because we can modify HTTP requests to have those tracing IDs. But with communication that is non-HTTP, so for example, the communication path from the card service to the Postgres, which is to the Postgres database, which is TCP, we don't have a way to get around that. So we can't reuse the card service, unfortunately. So what we're gonna have to do is just duplicate the card service. But the nice thing is that Cardinal will detect that for you. And that was one of the reasons why on the dependency annotation, we indicated the protocol that it used to communicate, and it will just duplicate the card service. So for that dev flow, the traffic for that development version will flow through the dev version of the front end, the dev version of the card service to the dev version of the Postgres database, and also the dev versions of the product catalog service. And we can see that actually working once I click on the So you can see that now when I use that dev version, it was seeded with 2 items in the database. And notably, when I, at some point, go back to the production version, I think I'm going to do some cleanup here beforehand. When I go back to the production version, you'll see that now this production version is, we can more easily see that this production version is using a separate database. So our carts are completely independent of each other. And now I'm doing testing on a completely different database. So in that way, we've got the kind of state isolation that we've wanted. And I think that will, once I delete, that will end the demo. There was one more that I was planning on showing if the live version worked and if we had time, but I'll stop it there so we can at least kick off discussion, because I believe we're almost 10 minutes to the hour. But I think that pretty much concludes it for the demo. And then let's see if I've got any more slides left. Cool. Yeah, and I think there's actually one more slide that I kind of want to show off. So we'll let's see. Stop sharing for a sec, and we'll share again. Cool. This is just a kind of to reference the discussion earlier about the trade-offs that I was talking about when we first initiated this conversation about Cardinal, where we were talking about how there's this kind of implicit trade-off that we're making between the desired isolation of the workflows that we want to get the resource efficiency that we're getting, given the approach that we're taking to try and test our divergent services, and also the similarity to prod. And I've kind of, Edgy has very kindly created this representation to compare us across some products that you may have heard of that are similar to Cardinal. So that first one is the multi-cluster approach that we were talking about at the very beginning of this presentation. With that approach, you get the complete isolation that you want and separation. You get the similarity to production, but you get the least maximal resource efficiency. But I don't know if you've ever heard of products like telepresence that allow you to connect your local machine directly into your Kubernetes cluster. You get a little bit more resource efficiency because you're able to use your local versions, and then you get some similarity to prod, but there's less isolation there. And then with vClusters allows you to completely duplicate clusters within a cluster and kind of create virtual clusters. And there's also some trade-offs that are being made here. And so Cardinal kind of aims to be getting at some level of these trade-offs and at least give users an engine where they can configure the different isolation trade-offs that they want to be making, and as a result, also be configuring the different resource and savings costs that they want to get. So I think that's the last slide that I wanted to share. And then now I'll kick it off for some thank you and discussions. So there are a lot of questions, so I'm very excited to take them now and start the chit chat.
Go ahead. Anyone have some questions? Katie and Edgar.
What stops you from doing the non-HTTP stuff at the moment? Like the
You
database-
mean, yeah, so just to clarify your question, you mean what stops us from like reusing services that don't communicate via HTTP using our tracing system?
Yeah.
Yeah. So, well, in terms of easy answers, in terms of simplicity, HTTP requests are nice because you can easily modify headers, use it with HTTP. And so that just gives us an easy way to implement a tracing system that routes traffic. With other communication protocols like a TCP connection, it's a bit harder to implement a mechanism, or there are less tools as far as I'm aware of, and you can correct me if I'm wrong, to actually modify the messages in flight. So, maybe one day, but I think that's what's stopping us right now. I don't know if you want to fill in the gaps there, Edgy.
No, yeah, I think that's it. So like HTTP is very easy to add, trace ID and follow that, inject and read. Anything else, TCP doesn't provide any underlying layer for these. So of course, depending which protocol you implement on top of these, so it might be that you start getting specific into, okay, that's a Postgres like protocol or Redis, like whatever specific protocol I have to implement on top of that. But basically, we need to guarantee that we can identify the traffic in and out of a given service, right?
Does that answer the question?
Yeah. You had mentioned a sidecar at one point. Is there something other than the normal Istio sidecar in process? Or like, does this preclude? Do you have to have an application that was already built for Istio or using Istio? Are you doing that same injection? Like, what is the actual thing that you're adding to the manifest when those annotations get put in there?
Yeah, that's a great question. And so the actual thing that we're adding is, so there is this Cardinal Manager service that we are deploying inside the cluster within called a Cardinal controlled namespace. And that manager service that we deploy inside the cluster is constantly polling the control plane, which is a cloud hosted service, for the updated cluster resources of the service. And then based on those cluster resources, which are K8s primitives like deployment specs, service specs, etc., and then also Istio traffic routing rules, it will do two things. It will essentially do the equivalent of like a kube control apply on those cluster resources to make sure to so that the API server, the K8s engine, will apply the necessary changes to the cluster topology. And then we will take those Istio, the updated Istio rules, so the virtual service rules and the envoy filters, and we will send that request to the Istio control plane, which then will adjust the Istio sidecars, which are also, Edgy, correct me if I'm wrong, also deployed alongside each of the services. That then allows us to do the traffic management in the way that we do. So I think to answer your question, yes, we deploy a separate Cardinal Manager sidecar that is constantly sidecar in the sense that it's just one thing that's deployed in a cluster, but then that's constantly polling, applying different K8s resources, and then it will communicate with an Istio control plane that then applies those rules to Istio sidecars that are deployed next to each of the services. So yeah, that's kind of what's going on there. Does that answer your question?
Yes. So it's the normal Istio data plane that would exist
Yes.
in any service mesh, but then you're doing the like mapping of endpoints and adding some extra filters and modifying that as you're using the service mesh for service mesh things and have your own control plane writing on top of that.
Yeah.
Exactly. Yep.
And
You may-
also like
Oh, good.
also just like we also add in like some configurations, right? Now, there's like the envoy filters to actually do a little bit of that. So going a little bit beyond like the more standard like Istio configuration, actually using envoy filters, especially for the dynamic part where I have to constantly check, oh, there is a trace ID XYZ, where should I route that? And then there is a dynamic component of that.
Yeah, you may want to. I would suggest just tweaking the terminology there. The Cardinal control plane is an operator in Kubernetes terms, right? A sidecar. If it doesn't run adjacent to the workloads one-to-one with pods, then that's a sidecar. Like the Istio stuff would be a sidecar. Just so expectations, right? It's just a thing in a namespace that does work in your cluster. Like that's just an operator in Kubernetes terms. Because I think that's where Greg's confusion was. Sidecar really means like a very specific thing in the heads of Kubernetes people. So
Yeah,
just a thought to clarify the terms.
You're completely right. So like the Cardinal manager it's not operator like we didn't implement like in the specs is basically a service running in the Kubernetes that is controlling Istio, but the sidecars are the Istio sidecars.
So how does this fit in with like Helm charts, and then also secondary? Well, I'll ask that question. I mean, what do you? I mean, yeah, talk to me about that world. It seems like where's this fit in? I mean, where do people actually have to make these changes? For the plugins, for the other things, do they have to do it within a chart itself? Do they have to do, what's the mechanism?
Yeah. So yeah, I can start by answering that question. So right now we don't support Helm, but at the end of the day, and so right now we only support deploying just plain Kubernetes manifests, but we are very well aware that a lot of people are using Helm charts to define their Kubernetes applications nowadays. So very very shortly, Cardinal just I think launched very recently, but shortly we want to accommodate how users can use Helm charts in their existing Helm chart infrastructure, and then add the Kubernetes or the Cardinal annotations to that, to then deploy that Helm chart or deploy their application using those Helm charts using Cardinal. But yeah, as of today, we don't support deploying with Helm charts. We only support using Kubernetes manifests, but that's definitely something that we are planning to support.
And then I had a question about services that are not talking HTTP using gRPC or those mechanisms. How do you fit in those situations?
Yeah. So any services that are not communicating via HTTP are anytime there's a flow that requires depending on that service, those services will just end up getting duplicated, essentially.
You have to duplicate it at that point. Okay.
Yeah.
So I have a question.
Yeah.
So from what I understand, like if you did a multi namespace approach, like each application has to be independently configured, like service.namespace.svc.cluster.local, like to address it. And so just to clarify with Cardinal, applications don't need to be reconfigured for different endpoints, like that proxying is being done by Envoy. Am I understanding that correctly?
You mentioned applications that are deployed in multiple namespaces. So are you referring specifically?
Yeah, if you're doing the namespace approach to like isolating things, like each application has to know which namespace it needs to talk to, for like a feature environment or for like a dev environment. But with Cardinal, that configuration can be static. Like if the front end needs to talk to the back end, it would talk to backend.namespace.svc.cluster.local, and it's the flows that redirect which backend it goes to, and the front end service talks to the same endpoint the whole time. Am I understanding that correctly?
Yes, exactly.
It's very similar with the service mesh, right? So with the service mesh, basically, as soon as you resolve an endpoint, it doesn't mean you can go to that endpoint.
Right.
Because you can have the mesh configured wherever you want it to go based off of other information. So if it has a trace header, then they default to whatever that trace header says. Oh, well, I need this version of that service, and I need something you could do with a service mesh, but it gets very complicated very quickly, so no one ever does.
Right.
But
Yep.
if you have another layer on top of it that's doing that topology mapping, then it's very easy to say, oh, well, I saw you came in with this trace header, a part of this flow. So instead of going to the normal part, I'm going to redirect you somewhere else. Based on
You explained that way better than I could have. Thank you.
It's almost like it's his job to explain these kind of things to people.
Yeah.
I could tell.
This thing before and like regenerating all those configs for each application is a pain.
Well, so then you have a system that just generates all the configs for you.
Yeah, exactly.
Yeah.
This is like a combination of builder service, right? It's like it is literally copying the existing manifest running in the cluster. And so when you create a new flow, it just says, oh, well, I see this running now. I will augment it with whatever script or annotations you've been able to do to adjust it. And off you go. It is like telepresence on steroids, is what I would say, because telepresence let you do that with a single service.
Yep.
Making that happen across multiple services is really tough.
In the matrix.
And with like external services that telepresence can't help you much there unless you literally put yourself in between it and Stripe or whatever it is.
Yep. Yeah. I think one way of saying like this is like it's almost kind of a compiler that sort of speaking like assemblers, like speaking like Kubernetes resources, right? So we're kind of compiling, like you get your cluster topology and kind of this like aggregation of like different flows and kind of render these as a bunch of resources that are just kind of apply. So it keeps constantly reconfiguring your cluster to achieve this partition. So it's basically you have like in principle like you don't need like multiple namespaces, right? So I have a single namespace, a bunch of pods, and then you connect the pods using the service mesh to enforce a given configuration. One thing I didn't mention, like right now we're not enforcing these, so like this is kind of if I have the notations, yes, but like we're planning, of course, like adding the possibility to enforce these. It means like, oh, if like one of the requests don't have a trace ID, agent should drop it, or if it wants to, or is being routed to a place that is not defined by your cluster topology, I'm going to drop it, and of course, like alert you. Right now, we're kind of not enforcing these. It means that you still could bypass that. We're not enforcing the thing, but we can really enforce these where your application has to follow whatever is specified as the topology. And if not, we are going to drop and alert you about that.
Product roadmap question. So I guess a lot of stuff that you guys demoed today was using a CLI and doing things imperatively. Is there current support or future support for like CRDs that live in a Kubernetes cluster and doing all this configuration declaratively?
The Andrew, correct me if I'm wrong, but the kind of the flow spec and the template specs work that we've been working on recently will help you define some of that, right?
Yeah. I think so. So like again, like we mentioned, like we didn't do a full like depth implementation. Like even like you said, like we don't have actually operator as the Cardinal manager is more like it's a normal service running, but is controlling some of the things there, but doesn't like follow the normal standards of an operator. I think we do have intentions. That said, like it's kind of the implementation is kind of stateless. We kind of re-render everything in a very deterministic way. So it's a more declarative way of doing this. The internal implementation, although we're using, of course, the CLI to control and adjust this. And I think there are plans to moving it further, and also like not only from the client, probably like you can control this from different means, right? For instance, like probably would be interesting like having ways of having this like nice integrations to CI/CD pipelines and other things like that as well.
Yeah, and embedding bash scripts and YAML and annotations is going to be fun trying to troubleshoot as that scales. I know Nginx was the one, they had quite a lot of details you could do with annotations, and I think after experiencing some of those pains, people did move more towards like policy CRDs where if you have a well-defined thing you want to do, you create a CRD for it so that then it's not as jumbled up with the rest of the manifest, and like you can apply that same policy against multiple resources much more readily. You can kind of play nicer with some of the hooks and things that are in Kubernetes. So like if I want a policy controller looking only for things on your specific policy CRDs, I can do that much easier than having to like inject that logic on all the annotation spots that you're currently putting things in. And then just YAML and annotations, it's so easy to get one space wrong and the whole thing goes kablooey.
Yeah, no, precise. I think like then initially we would like do CRDs, and then we say, okay, maybe annotations can get kind of, easy, and like it maybe it's a low friction point, because like CRDs does kind of have a custom language, right? Like annotations, maybe it's a little bit like less friction on that. So we start with annotations, and then we rely a little bit on the plugin. Again, that's something to experiment with. But the idea of like creating these plugins, and the plugins would be like Git repository with some kind of API. There's basically right now I have like 2 functions that you have to fulfill. And then a lot of the logic can live in that plugin, right? Even that kind of is scripted, that is embedded, and the YAML, I mean, eventually that probably should live inside the plugin itself. But like, it's a good point. I think eventually we need to actually add more, as we add more power and more flexibility to this as well. We really have to go on the CRD road to allow like other kinds of manipulations with that as well.
Just a quick question. We have like ephemeral deploys. We have canaries. We have things like that, which very, very useful. My question is on the canary side, meaning it seemed like this was solving the problem of internal to another internal service to test things. But would you have to use other mechanisms so that if you don't want externally people to hit that site, that's how are you preventing that? I mean, are you using some other mechanisms to do that, or just rely on the normal way of saying, hey, your traffic shouldn't go here or can go here? Does that make sense?
So the question is, I think I got the last part, which is how are you managing what traffic people are able to access based on the flows that they have? And then
your demo was internal, right? So you had these services talking internally to a dev service or a prod service or whatever. But you also have people in a live production world that are coming into the system as well. And there are mechanisms to prevent that. But do you rely on those external mechanisms, or do you have something in your own setup here?
I'm actually unsure. Edgy, do you know how we handle that?
So like right now we do, like, we have, of course, maybe I don't know if it's a full flexible implementation, but like, what we're also controlling the gateway part of that, which means that basically when you create a flow, we inject like a trace ID at an entry point, and then we propagate these from that entry point downstream. So you should be able, of course, you have to configure probably your domain. Like one thing we did is like we add the flow ID as a subdomain, depending on how we're doing these. And of course, then you have to configure your network to accept these. But then you could really create like subdomains, each one for one specific flow. The trace ID is getting injected at the entry point and then propagates downwards, and that's basically how you control access. But you could have like front-end access for every flow if you wish.
Okay. Yeah, thank you. Any other questions or comments? All right.
Sweet. Thank you, guys. I think I have one more slide here. Yeah. So I'm glad that our live demo didn't work, actually, because now I can urge all of you to go and try it out live within our docs. So highly, if anything that we discuss here interested you, please check out our docs and learn more about how it works. And then Also, if you want to check it out in your own way, we have a playground where you can kind of run through the exact same demos that I was trying to show via Codespaces, GitHub Codespaces, and then we've also got a forum. And then there's this little cost calculator which somebody on our team has made to show how we reasoned about some of the potential cost savings that you can have by reusing stateless services in the way that Cardinal allows you to. So just some resources. I think there's one more link I need to add, but then I'll share these slides with Paul, and then maybe he can circulate them. But yeah, want to thank everybody again for the time and the forum for us to share what we've been working on. And then yeah, so thank you guys so much.
Thank you, Teddy and Edgar.
Thank you, guys. It was a pleasure to meet you guys and present to you our work.